All right, so here's the solution or the code for the exercise number 9. And then the next one is exercise number 10, wherein the x and y coordinates as function of time t of a projectile fired with an initial velocity v at an angle theta with respect to the ground is given by x is equal to v times time times cosine angle or theta. And then for the height, okay, so x is the distance traveled, and then the height is the y is the height. The y is computed as v times t times sine times theta minus 1/2 times g times t squared. So yeah, it's quite long, but yeah, that's the formula for the height. So using these formulas, write code that allows the user to input for the initial velocity, say 350 meter per second at an angle, say 25 degrees. So this is the initial inputs. Okay, and then display a table of x, distance traveled, and y, which is equal to your height. Values for a projectile fired at time interval 0 to the total time of flight. So that is t is equal to 2 times velocity times sine times theta divided by g. Seconds with increments of 1/2 second. So hint, remember to convert to radian measure. All right, so to make it simple, let's use a graph. So we have here the x and y coordinates. So y is the height, okay? And then x is the distance traveled, all right? And then let's say we have this angle right here, theta. And then let's say you have fired an object, okay? At, of course, we'll start with 0, okay? And then let's say we have assumed that we have a force, okay, of 300 or a velocity of 350 meter per second, okay, with an angle of 25 degrees. Okay, so this is the peak value. Okay, this is the maximum value or maximum height. And then, of course, it will fall again, and then it will reach or eventually reach the ground, and the height now is 0. Okay, so that's the logic regarding with this one. And here's the expected output. We have the initial input or yeah, initial velocity at 350 and then 25 angle in degrees. So I have already created this one. Exercise number 10. Number 10. All right. So let me just show to you guys the result for now. 350 and then 25 degrees in angle. So we have here initial, okay, initial time is 0. So of course, 0 in distance and then 0 in height. At 0.5 second, it already traveled a distance of 158.60 at a height of 72.73 until it reached the peak value. The peak value is 1,115 right here at exactly 15 seconds. So if you're going to draw that one at exactly 15 seconds by height, so let's say this is 15 seconds, okay? It reached the peak value of 1,115 in height, okay? And then of course it will fall, okay? 15.5 seconds, so it's now 1,114, 1,111, up to its 30.16 second. So at this point, 30.16655, it traveled a distance of 9,569. Okay, and then of course the height were already 0. Okay, so that's basically what we are trying to compute here. Then the total time of light is 30.2 16655. Right? If you're going to convert that one into decimals, so you have to round up the 6 into 7, so 30.73. All right. So yeah, you can create or come up with a program where it can calculate basic physics uh, problems like this one. So yeah. Hey, so let me just explain to you guys the code. So I have declared those variables as single. We have t for time, d for distance, h for height, t flight for the total flight, bo for the velocity, and then angle is for the angle. And then we have a constant value here for g, wherein, if I'm not mistaken, this is force value, which is 9.81 or 9.8665. We have two inputs. So the input for the velocity and then input for angle. And then we have this clear function right here, and then the headers, and then their values down below, and then the computation for the t flight. So where did we get this one? This one came from this t flight right here. 2 times v times sine theta, 2 times v times mat that sine theta is the angle. And then we have to multiply this one by mat that pi divided by 180. Since by default, this one is in degree, so we have to convert that one into radian. We have to multiply it by mat that pi divided by 180 divided by g, which is this one. All right, for the next one right here, so whatever is the computed value right here will be formatted into two decimals only, and two. Okay, and will be shown to the text box 3.text. Text box 3.text is this one. Okay, the flight, time of flight. And then we have here the values or computed values on the data grid view. So we have here the formula for the distance, formula for the height, and then their arrangement in data grid view. So the first one is a distance traveled followed by the height. And then it's incrementing by 0.5. And then the last one will show us the final value, which is the 31 point something. Okay, so you have to add this one since right here, let me just show this one. So what is that? 35. 350, 25. Because as you guys can see right here, it's incrementing by 0.5. However, okay, 30 plus 0.5 will not be shown right here anymore since, yeah, it wasn't able to reach the 30.5. So we have to make another computation, which is outside of the wall structure for us to be able to solve the 30 point something. Okay, and then the zero distance or height. Okay. Anyway, so yeah, that's how it was computed with this program. Anyway, so I'm not expecting you guys to fully understand this one right now. I just wanted to show that this is, how you do it. This is how to do it. Okay, something like that. All right, so let's now move on to the next one, which is exercise number 11. So in here, given different values, assume all are integers listed in the list box and determine the sum of all the values. So we can actually manually input a value in this list box and then compute it, okay, and then show the result on the text box. So I already have created this one. Exercise number 11. So we have these values right here, okay, which came from the properties collection of the list box. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, 3, 5, 2, 4, 6, and then 1000. So if I click compute, all of those will be added with each other. Okay, sum is 2479. So how did I do that one? Okay, so I have declared two integers as integer, okay, and then we have this counter variable wherein it will read cell by cell. Okay, so it will start with 0 cell and then we'll move to the next one. Okay, so you have this function right here, list box 1 dot items that count minus 1. So this that count minus 1 right here will be reading all of the cells of this list box. Okay, and then of course it will be added to this variable total. Okay, and then right here it will be shown to the result total. Okay, and then take note that it will be converted to string, so it's not a number anymore, it's not integer anymore, but it's now a string. Okay, so as a result you will have this one. Anyway, so that is just a quick example regarding with this function count minus 1. All right, so this is now the most important regarding with this module 9. Okay, so the reason that you guys are still here because this is what you want or this is what you need to learn. Why? Because these examples right here or these exercises right here will be part of your final exam. So we have 12 examples in here. And once we're done with this one, okay, then we're done with the module 9. So the rest are just exercises, okay, that you can practice with for you to enhance your programming. Okay, so for the number 1, we will be needing a notepad in here. So it says here, tell how many times does each of the following loops iterate and what is the final value of the variable x in each case. So for the number 1, it is asking how many times it will iterate and then what is the final value. Okay, so let's check this one by one. So we have an initial value of 5, okay, and then it's incrementing by 1, okay. So one thing that you need to check before you increment this 1 by 1 or before you can write here 6 is you have to know whether this one is still true, okay. So again, if you are using while, so you have to know that this one is still true, because if this one is already false, then you have to stop iterating or you have to stop looping this code right here. Okay, so in here, 5 is initial value. 5 is less than or equal to 30, so it's true. So it will keep on looping. So plus 1, so 6 is less than or equal to 30, which is still true. So that is why it will still keep on looping. 7 is still lesser than or equal to 30, then it is still true. So it will still keep on looping. 8 is still lesser, 9 is still lesser, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there you go. Now, can we write here 31? Hello? Hello? Are you guys still there?
Yes, sir.
Now, my question here is, can we add 31? I mean, can we still proceed if we have a value of 31 right here?
No, sir.
So no anymore because 31 is not lesser than or not equal to 30. Okay, wherein this condition is already false. So as long as this condition is true, then you can still keep on going. However, once this one became false, and that's the time that you have to stop looping. So if you guys are going to count those numbers, it will give you a total of 26. Okay, not 25. So 26 because we have started in counting to its original position, which is 5. Okay, so number 1 will iterate 26 times. So just count as 1. 5, 10, 15, 20, 21, 22, 23, 24, 25, 26. All right. And then what is the final value? So whatever is the final value in here will be, of course, your final value. So I hope that you guys were able to follow the number 1. Okay. So this is
Yes. Sir.
very good. How about Mr. Zua and Miss Dulay?
Yes, sir.
Mr. Zua, are you there? Okay. So I guess he's not around. Anyway, for the number 2, so we have an initial value. So the same question, how many times this will iterate, and then what is the final value? So let me answer number 2. Or anyone who would like to answer number 2? Miss Dulay, Mr. Miss Begeo. So we'll start with 10. And then it will increment by 5. So we have to check if this one is 2. So 10 is less than or equal to. So
15.
15. So this is the next value. Yeah, that's correct. This is the second value.
20.
20, 25.
25, 30. 35, 40, 45, 50.
Okay. So is this the final value?
Not yet.
Not yet. 5. So if we'll check whether this one is the final value or no, so we have to replace this x by 55. So 55 is less than or equal to 50. So is this true? This is false,
No,
right?
sir. Huh?
Now, once this one became false, okay, then we will stop looping or iterating that program already. Okay, so that is why 55 is not part of this iterations. Okay, so it will only up to 50. So in here, just count the iterations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it iterates 9. And the final value is 50, okay, which is this one. Were you able to get that one, Miss Begeo and Miss Tulay? And Miss
Yes, sir.
Very good. So yeah, this is how simple your final exam is. So we have programming part and then this one. Right, so for the number 3, same questions. How many times this will iterate and then what is the final value? So take note, we are using until. So this will keep on iterating while this one is false. But once this one became true, then that's the time that we will stop looping. So in here, we have an initial value of 60. 60 is equal to 40. So false, we will still proceed since it is still false. So it's decrementing by 10, 50. Okay. So 50 is still not equal to 40. So it's still false. So we can still proceed, I guess. 40. So 40 is already equal to 40. Wherein, 40 is already equal to 40. Wherein this one is already true. And since we are using until, okay, once this one became true, then that's the time that we have to stop looping. Okay, so that is why 40 is not included in number 3 iterations anymore. So this will only iterate 2 times. And then the final value is 50. So again, until is the opposite of while. Okay, it will loop only if we have false condition. And will stop looping if we have true condition. All right. So are we clear with number 3?
Yes, sir.
So you
Yes,
can
sir.
always go back. Just go back with our first examples or syntaxes right here. Okay? To avoid confusion. Para hindi kayo masyadong malito. Alright, so where are we now? Okay, number 4. So we are still using until. Again, it will only iterate if we have false statement. So 100 and then the final value. Okay, so let's analyze this one. So initial value is 100, wherein we have the condition 100 is greater than 70. So is this true?
Yes, sir.
So again, since this one is already true, then we will stop looping there already. Okay, since it will not iterate, since we've never had a false condition in it. Because initially, this one made this one already a true statement. So this will iterate, okay, 0. Okay, it will never iterate. And then the final value is none. All right. So I hope we are clear with that one. So it didn't even reach this one, x minus 20. So at this point, it is already true. All right. So clear so far?
Yes, sir.
Yes, sir.
Okay, so for the number 5, so the same question. How many times it will iterate, and then what is the final value? Okay, so initial value is 100, which is greater than 75. So we are using while. So while this condition is true, then it will keep on iterating. So 100 is greater than 75, so true. So it will iterate. So the first value is 100. And it's decrementing by 5. Okay. So the next one is 95. So next, let's see. 95 is still greater than 75, so it will be part of the iterations. And it will decrement by 5 again. So 90. 90 is greater than 75, which is still true. So it will be part of iterations until you will reach the value of
80.
80 only. Let's see, 80 is greater than 75, which is true. But once you have reached the value of 75, 75 is not greater than 75 anymore. So it will not be part of your iterations anymore. So in here, we only have 5 iterations. We only iterate 5 times. And then the final value is 80.
80.
So that's how you verify what is the final value and then how many times it will iterate. And for the number 6, oops, what is the one that we are trying to answer? Sorry. So the one that we had answered is number 6. Sorry for that one. Number 5. Okay, so let's answer number 5. Okay, so in here, how many times this will iterate? What is the final value? All right, so in here, the initial value is 15, and we're using while. So is it less than or equal to 45? So this is true. So the first iterated value is 15, and it's incrementing by 5. 20 is still lesser, okay, than 45. The next one is 25. So 21 is still lesser. And 30. So 30 is still lesser. However, okay, However, we have another condition wherein, oops, wherein if x is greater than or equal to 30, oh, my bad. Okay, because, no, it's only correct. It's correct. So if x is greater than or equal to 30, then exit 1. So in here, as you guys can see, we have reached 30, wherein 30 is already equal to 30. Then it will exit while already. So in here, our final value is 30, and it iterates 4 times. Final value is 30. Right? So this is one thing that you guys need to check. Okay. So yes, we have a condition right here, but we have another condition right here. Okay. So I hope we are clear with this one. Are we clear? Or any question or clarification so far?
Answer.
All right. So, okay. So were you able to follow, Mr. Zua? Seems that you are having a problem with your connection. Anyway. All right, so let's answer now number 7. Okay. So you can replay the video that I will upload later on, Mr. Zua, so you can go back with the slides that you have missed. Okay, so let's now answer number 7. So number 7, so we have until in here, so it will stop looping once the condition is false, I mean true. Okay. How many times it will iterate, and then what is the final value? Okay. So initially we have 75. Then compare it with this one, this condition is equal to 10. So 75 is less than or equal to 10. Okay, wherein this one is false. Okay, so that is our first value. So plus 10, 85. Wherein 85 is, not less than or equal to 10, so still false. So this is now your second value. Up to 95, 105, 115, up to infinite. So we also have some cases like this wherein it will never make the condition true. So in other words, we have infinite loopings in here because this will never make the condition stop. So in here, for the iterations, you can just write here infinite, and then the final value is also infinite. Okay, or infinity. So are we clear regarding with number 7?
Yes, sir.
All right. Really hope so that you guys were able to follow. Anyway, so let's proceed with this one. So how many times it will iterate? What is the final value? So for iterations, we have to check the initial value. So 100 is greater than 70. So this one is true.
True.
And since we are using until, okay, this will actually never iterate because initially 100 is already greater than 70. And in until, once the condition is true, then it will stop looping. So it will never iterate, and then the final value is 0. And, all right. And for the number 9, okay, so how many times this will iterate? 1. So we will start with 0. It's incrementing by 1. So by default, we didn't declare the step value. So it will increment by 1 by default. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you're going to count this 1, it will give you 11 iterations. And then the final value is 10. Oops, 10 right here. Okay. How about number 10? Could you guys please answer number 10? How many times it will iterate? And then what is the final value? So we have an initial value here of 0 and it's incrementing by 2. So 0 plus 3 is 2 plus 2, 4 plus 2 again 6, 8, and then 10. So if you're going to count this one, we have 6 iterations and then the final value is 10. All right. So let me change this one. Okay, instead of step 2, let's have step 3. So initial value is 0, and then plus 3 is 3, plus 3 again is 6, and then plus 3 again is 9. Now, how many times does one iterate if we have step 3 right in here?
4.
4, and then the final value is 9. Okay, so as simple as that. So we have 2 more. 11. So how many times this will iterate?
11, sir.
So 20 is initial value. So let's see if it's 11. 20, so it's decrementing by 2. 18, 16, 14, 12, 10, 8, 6, 4, 2, and then 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very good. It's 11 times. And then the final value is 0.
0.
About number 12. How many times it will iterate? What is our final value?
5.
5. So initial value is 0. It's incrementing by 3. 6, 12. 1, 2, 3,
12.
4.
5.
And then
12.
the value is 12. Okay, very good. So yeah, that's it for the module 9. And then the rest, okay, so you guys can explore this one once you guys are done with your lab number 9 and 10. Okay, so you can only proceed with this one once you're done with those laboratories. So do not proceed to the next slides that we have in here unless you're not finished with your activities or your laboratories. All right, so that's it. And the next meeting that we still have, okay, or the meetings that we still have, okay, this coming Thursday and then this coming Monday, April 12th, will be your free time, or actually your time to finish the laboratories, okay, that I gave you. So your final exam will be on Thursday, next week, Thursday, April 15th. All right. So coverage is, of course, the module 7, 8, and 9. So any questions so far before we end our meeting?
Wala, sir.
Answer.
Okay. So again, you can message me anytime if you have a question or a problem regarding with our subject. Coverage is the module 7, 8, and 9. So 3 modules. Okay. All right. So thank you guys for coming, especially to those 3 of you who have still, used your time to listen with my discussion, because without you guys, I won't be able to discuss this, remaining slides. Anyway, so again, thank you and see you guys when I see you guys again. So basically, this is already our last meeting for this subject.
Bye, sir.
Thank you, sir. Bye, sir.
Goodbye. Goodbye to all of you. So you guys may now go.